Hello, my name is Matthew Butler and I'm going to take you through how we applied the current HEPA filter guidance to the Addenbrooke's hair disinfection study, so practical applications guide. So I'd really encourage you to, if you haven't already done it, to download the guidance, and you can simply Google NHS HEPA and it will bring up this page which you can download as a PDF print. Essentially the introduction sort of says why this is important. So focus on ventilation's highlighted areas of high risk due to performing inadequate ventilation, particularly in older hospitals, although as we all know there's some quite notable newer hospitals which have poor ventilation, and that can then increase the risk of nosocomial infection. And we see that if you looked at just hospital-acquired COVID as up to the 1st of June 2023, that we're getting rates around about 30% of inpatient hospital COVID being acquired in that hospital, so the patient testing positive after 7 days of an admission. What we also know is that there's wide variation of the risk of getting hospital-acquired COVID by trust, and whether there's risk, this risk range goes from 0%, so some hospitals have really managed to keep down the numbers to 3.4%, so almost 1 in every 30 patients after 7 days developing hospital-acquired COVID. And the narrowing of the range of risk would be the goal. So if we can bring the worst performers down to the average, then that would save a huge amount of extra cost associated with treating patients for these nosocomial infections. And sharing best practices is what we're here for today. So just looking at the HEPA filter technology, so this is the particular technology that one of the guidance documents advocates for implementing. And essentially these filters are made of randomly arranged plastic fibres that are very small and fine, and through 3 methods manage to trap particles. So effectively a HEPA filter is the filter itself, and then the power source to the fan, and a casing which directs airflow. But all in all, it's essentially a filter like you would find in a FFP3 respirator, and the same material actually is found in surgical masks as well. So it's common for HEPA filter devices to also have other filters in front of them to extend the life of the HEPA filter itself. So those can be sort of dust or lint filters, but also quite relevant to healthcare settings are the addition of carbon filters. So it would be useful if you look for devices that also include those which can filter out volatile organic compounds from all the cleaning materials that we use and other disinfection tools that we use, but also in poorly ventilated wards, particularly where patients have a varying level of urinary or fecal incontinence. It can be really helpful to keep down odours. So when you're coming to applications and sizing, so the standalone filters are mainly what you're going to be looking at. They can be suitably located in any room particularly, and they're plugged into standard electrical sockets, so they don't require any particular installation, although the location is important, and I'll talk about that a bit later. The clean air delivery rate, or CADA, is what the manufacturers will usually quote you, but just be wary that that expresses how the device will perform in a standardised test room, and not necessarily in a ward which is busy with full of people and furniture. And actual performance of whichever machine you decide to go for will depend on its location in the room size, the layout in the room, where the beds are, the background ventilation rate, so if you have natural or mechanical ventilation, as well as the device design itself. So some are designed for corners, some are designed to go into the middle of the room, some are designed to go against the walls, and also how well that unit, like everything, has been maintained. And the installation of HEPA filters can be considered to be additional equivalent air changes. So you may already know this concept of air changes per hour, or ACH. Essentially, if you filter on top of that, the amount of air that goes through that filter can add equivalent air changes. So if you've got a treatment room with 6 air changes, you can achieve 10 by adding 4 equivalent air changes by filtration. And hence, to meet the requirements, the number of devices required can be dictated by the existing background levels of ventilation. So this is really important, that you actually understand what your background levels of ventilation are, and typically in my trust we get around 2 to 3 air changes on hospital wards. Our hospital was designed before HTM 0301, when 2.5 seemed to be the target. And for those of you that aren't familiar, so this is HTM 0301 Appendix 2, summary of design conditions, and as you can see, this column here dictates what air change rates you should be going for, and this is for a number of reasons, not just for infection control but also reduction of medical gases. And highlighted in the first row, as you can see, the majority of the hospital space would come under this category of general ward of level 0 and level 1 care. And as you can see, those which form the majority of the hospital estates that we have in the NHS should be achieving a minimum of 6 air changes per hour. And we know that around about 50% of the healthcare estate fails to meet this guidance, bearing in mind this guidance has been in place for many decades. So in the Addenbrooke's disinfection study, we had this conundrum of, well, where do we put these filters? And you can see in blue, this is where we ultimately decided to place them. But how do you decide where to put them? And thankfully, the guidance helps you with that. So if we go to section 7, engineering and operational considerations, essentially each trust should have a ventilation safety group, and they will help you. And they will already be considering airflow strategies which can improve the ventilation. And this requires that all factors, such as the airflow rate that you've got through the existing ventilation, the mixing, distribution, dilution, as well as thermal buoyancy, so what heating systems do you employ, and also the busyness of the place, the occupant movements must also be considered. And airflow patterns and ventilation rates can be evaluated using a variety of tools, so indoor air quality monitoring, air velocity measurements through anemometers, checking that the ventilation coming through existing vents and ducts is adequate, but also visual methods such as smoke tracing to check whether pressure differentials are as they should be. And then more technically, you can use computational fluid dynamics. So if you've got a new build, that may well have already happened, to decide how the airflow system is going to perform. But you can use other particle tracing methods and other forms of airflow assessment to identify the optimal locations. In ARDS, we used this method where we deployed lots of indoor air quality sensors, and on the left you can see a natural experiment where one of our air cleaning units was turned off, and on the right, when the air cleaning unit is in fully operation, it's easy to see how the air cleaning unit on the left being off leads to quite dramatic increases to particulate counts. But if you draw your attention to the right hand image, even with the air cleaning unit on, we saw that we were not controlling the particulate counts in the bays adequately enough. Hence why we opted not only to have corridor air cleaning units, but also air cleaning units that were situated in each of the 6 bedded bays, although we did use smaller units in the bays so that they didn't obstruct the windows. So just to go through some 6 key points, so these units should be positioned so that they don't interfere with care provision. The units that we chose to install were quite tall, but they were very slimline in their design, so that they didn't project out into the bays and enabled equipment such as hoists and commodes and things to be moved around them. Floor standing devices can be a trip hazard. So on ours, we had a base plate that was quite closely aligned with the actual filter itself to minimise that risk. Cables shouldn't pose a ligature risk, particularly where that's important would be mental health settings, and you might want to go for fully encapsulated units to fully get around that risk. You also need to consider people who have visual impairments, so they may not be able to see the units. When you're considering placement, particularly if they're noisy people with visual impairments would need to know what they're there for, and also where they are in order to avoid them. And it's also really important when you're thinking of where to place them that you don't block the inlets and the exhausts. So for our units, we had the inlet was the main front plate, and the exhaust was on the sides. What we noticed was that lots of things get stacked on top, and a lot of the units that you might see in hospitals have an outlet on the top, and you can be assured that that's going to be used as a table, and effectively blankets or pillows going to be stacked on there. And also it's really important that the device design should not be, topple, and our unit used a really heavy steel plate at the bottom in order to minimise that risk. When it comes to maintenance, it's really important that you make sure that they're wipeable. We know that biofilms can form quite readily in healthcare environments, and with the problem of antibiotic resistance, we really need to make sure that these machines don't add to surface transmission. So wipe resistant materials, and the units that we used had antibacterial paint and were steel in their stainless steel in their design. And also that filter replacement, you need to consider how easy that's going to happen. Our filters we took off the wards to change the filters, but actually evidence does suggest that the risks posed by filter changes are small, and they're unlikely to be such a significant biohazard as we once thought. But it is important that when new filters are installed that they must be correctly seated as per the manufacturer guidance. So that's my little bit there. I haven't gone into more of the technical aspects, but if you want to get in touch with me about how we commissioned our units, then feel free to get in touch. I'll make sure that my contact details are disseminated.